All right, welcome to Chapter 11. In Chapter 11, we're going to work with combinatorics. Combinatorics is a field of mathematics where we use the fundamental counting principle and permutations and combinations to predict how many ways something might happen or the probability that something might happen. So let's begin with some basic definitions. The fundamental counting principle simply means the number of possible ways that something can happen. Let's write that down. The number of ways something might happen. And if we look at this first example, let's say we have 5 shirts and 4 pairs of pants. We want to determine how many different outfits we can make. Well, let's think about what's going to happen. Each day we need to pick out a shirt, and each day we need to pick out a pair of pants. We know that we've got 5 shirts and 4 pants, 4 pairs of pants. So if we multiply 5 times 4, that will get us 20, which is 20 different outfits using your 5 shirts and 4 pairs of pants. I hope they all match because, you don't want to clash. Oh no. Next up is factorial. So maybe in math before you've seen that exclamation point. Exclamation points in math don't mean excitement. What they mean is multiplying consecutive numbers. Mathematics is exciting enough. We don't need a punctuation mark. So for example, if we wanted to evaluate 5 factorial, 5 factorial means 5, and then multiplied by all of the numbers before it, 5 times 4 times 3 times 2 times 1. So I can do this mentally. 5 times 4 is 20, 20 times 3 is 60, 60 times 2 would be 120. Now, a cool thing about factorial is that it doesn't really have operations that can be done to it. So like 7 factorial plus 3 factorial doesn't mean 10 factorial. 7 factorial times 3 factorial does not mean 21 factorial. With factorial, you just kind of need to write it out and figure it out from there. So if I wanted to figure out 10 factorial divided by 7 factorial times 3 factorial, I'm going to write it out. I'm going to go 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Now I promise you I'm not going to write those all out ever again. Then I know it's divided by 7 times 6 times 5 times 4 times 3 times 2 times 1. This business being my 7 factorial. I also need to divide by 3 factorial. So if I write it all out, I see that everything from 7 and down is going to cancel out. And then from here also, I could do some reducing. 9 divided by 3 is 3, and 8 divided by 2 is 4. So 10 times 12, well, that will be 120 as well. Okay, so that is factorial. In a little bit, or maybe in the next video, I'll show you how to find the factorial button on your calculator. You just hit the math button and you'll find it in there. Okay, next up, let's talk about permutation. So permutation is an arrangement of items in a particular order. So with permutation, I always remember that order matters. Order matters. So permutation is an arrangement of items in a particular order. So for example, let's say we have 10 students in a race. First, second, and third place medals will be awarded. So maybe they're, gold, silver, and bronze. And we want to figure out how many different ways the medals can be awarded, assuming that there are no ties allowed. Well, one thing we need to go back up here and do is add our formula for permutation. The formula for permutation looks like this. N, capital P, so N is a subscript, capital P, R is going to be a subscript, and then that's equal to N factorial over N minus R factorial. N minus R factorial. So that's our formula. We're going to come back to that a lot. This is our formula for permutation. So what we're going to do in this example is we're going to take 10 students and we're going to choose 3 of them to earn first, second, and third place, or maybe gold, silver, and bronze. So I'm looking at 10 factorial divided by 10 minus 3 factorial, and then that's the same as 10 factorial over 7 factorial. And a few seconds ago I said I'm not going to ever write out that factorial ever again, and this is what I'm talking about. I'm not going to write out the 7 factorial ever again because I know that it's going to cancel top and bottom. So 10 times 9 is 90. 90 times 8 is going to be 720. So that means there are 720 different permutations or ways that I could order the 10 students winning first, second, and third place. Next up is combination. So on the next page, with combinations, order doesn't matter. So combination order does not matter. So with a combination, when you're finding a combination, this is just an arrangement of items where order does not matter. Where the order doesn't matter. And then, of course, we have a formula for this as well. So our formula for n items taken 4 at a time where the order doesn't matter would look like n factorial divided by r factorial times n minus r factorial. So the only difference between a combination and a permutations formula is this additional r factorial in the denominator. So in this next example, we've got a chemistry teacher dividing his class into 8 groups. Each group is going to submit 1 drawing of molecular structure of water. He will then select 4 of the drawings to display. How many different ways can he select the drawings? So in the last example, gold medal, silver medal, bronze medal, or first, second, and third place, I know that I would definitely want to win first place. So order matters there. But in this example with this chemistry teacher, no drawing is more important than the rest. 4 of them are just going to be slapped on the wall. So it doesn't matter if mine is chosen first or last, because I just want it to be displayed, and nobody's any more important than anybody else. So in this situation, this is a combination. So to determine the number of arrangements that are possible, I'm going to take my 8 drawings and just choose 4. So 8, choose 4 where the order doesn't matter. And then this formula involves 8 factorial over 4 factorial times 8 minus 4 factorial. So let's write this out. I've got 8 times 7 times 6 times 5 times 4, and I'm going to stop there. 4 factorial, forget about that. And then I do have another 4 factorial, so I will write that out just to help me with my division. So this much was 8 factorial. This much is 4 factorial. And this much was the 8 minus 4 factorial, or in other words, 4 factorial. Let's do the simplification, just kind of let's do it in our heads. So 8 divided by 8, 6 divided by 3 would be 2, 7 times 2 times 5, that would be 70. So there are 70 different ways that he can choose, or she, or I guess it says he can choose 4 of the drawings out of the 8. All right, in this next example, I give you 4 scenarios, and I'd like you to think about whether or not each one of these would be a permutation or a combination. So determine whether to use a permutation or a combination, and then solve. So I'd like you to pause the video and do those, and then we'll go over the answers tomorrow.